All right. So today our lesson on 4-1 quadratic functions and their transformations. You don't have an essential question on yours, or do you?
Yeah.
Okay. Okay. It is. Because this is my previous notes, but I took off all the essential questions because we don't really answer them anymore, but it is what it is. Okay, anyways. So our parent function for a quadratic function that we've talked about before is just x squared. That is the most basic form for a quadratic. So we are going to go ahead, make a table, graph some points, talk about all of these things, and then we'll start doing transformations with each different type of example and see how the vertex changes, what happens to my axis of symmetry and domain and range and whatnot. Okay? So when I'm making my table, I'm taking my -3 and I would be squaring it. All right, so either do that in your head, take -3 times -3 to get a +9. If you're typing that in your calculator, make sure you are using parentheses around that squared, because your calculator will not square the negative. It would only square the 3 if you do not use parentheses. Your calculator is smart, so make sure you are typing in smart things, okay? Or using your brain. All right, so then my next one, I'm taking -2 quantity squared and getting 4. I'm taking -1 squared and getting 1. 0 squared, 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. All right, so we should see some of these numbers kind of repeat because our graph is symmetric. All right, so I've got -3, 9. This only goes up to 8 points, so I'm just going to go up one more extra. So -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. All right. We've looked at these graphs before, mostly just using like a Desmos calculator. So we should have an idea that this makes that U-shaped graph. All right, I'll make my points a little more distinct now. All right, so whenever I plug something in, I must square it. So the larger my x value is going to be, it's going to get very large for your y value. So we don't want to use very large numbers if I'm plugging things into a table. I want to use small numbers. So typically, that's kind of the set that I'm going to work with because the -3 and 3 already kind of get off my graph. All right, so I typically focus on those 5 points. So kind of like when we talked about absolute value graphs, they also have a vertex. So that's my vertex, that kind of starting point or the center of your graph. So in the parent function, that's just 0, 0, just like it was with a absolute value graph. And then we did things like move it up 2, move it left 3, all that stuff we will do with our quadratic parabola. We had an axis of symmetry that we talked about in absolute value functions. That splits your graph in half so that every point would match on the other side, right? That's 2 away. This is 2 away. Those are 3 away. That's 3 away from that axis of symmetry, so we can balance out those points. All right, that's a vertical line, so I write that as x equals. It is going through the x coordinate of my vertex, so that would be 0. All right, so domain and range, maybe you haven't talked about that in a while since maybe one of your first algebra classes, I don't know. But it's talking about all the possible x values for domain, all the possible y values for the range. All right, so all the possibilities for x, these arrows keep pointing out, so it's continuing forever and ever along the x-axis, right? I can plug in any number I want and square it, all right, as large or as small in the negative direction as I want. So that means my domain is all real numbers. So there's my little symbol for all real numbers, or you will just select it as the 3 words, all real numbers in Math Excel. But when we're writing it down, it's just short and sweet for that symbol. Usually in the back of a math book, you'll see that like boldface R font. Okay, the range is more interesting in a parabola. because the range is your y values, and if we take a look, there are no y values below my vertex. All right, so that vertex is a starting point. So it starts at 0, and then it's everything above 0. So I'd say y must be greater than or equal to 0. Okay. Next is either a minimum or maximum value. It cannot have both. All right, so the vertex is that starting point. So the vertex is going to kind of indicate, is that the lowest value or the highest value in this case? It is the bottom of the graph, so it is a minimum. The minimum value is 0. That is your y value at the vertex. Okay, so those are the things that we're going to spot in every graph, but next we'll start making transformations on that parent graph. All right, so here's our next 3 set of graphs. So I'm looking at number 1, I've got y equals x squared plus 2. Before I write anything in, let's see if we remember the transformations we were just tested on will help you with what we're doing now. All right, so I have my parent function, but then I have a plus 2 after. Do you remember what that does to your graph? It's going to move it up 2. Okay? So if I'm moving everything up 2, I'm taking these, we'll just focus on these 5 points, and they are all going to move up 2. That makes sense. All right, so instead of starting at 0, 0, it's starting at 0, 2. So moving it up 2 changes my vertex. All right, the next points were at -1, 1, and 1, 1, so those move up 2. Right, then I had the points at 2, 4, so they move up 2. And then it has that same pattern over and over, but I just shift things around. Okay, so my axis of symmetry, still splitting the graph in half, still writing it as x equals because it's a vertical line, and it goes through the x coordinate of your vertex, which is 0. My domain is all the possible x values. So once again, it's going to continue to spread and spread forever and ever in both directions. It just might take a while. So that's all real numbers for your domain. My range is affected by my vertex, kind of that starting point there. So that's the lowest it can go because that is my minimum value of 2. So that means y must be greater than or equal to that minimum value. Okay, I want to show you what you'll see in Math Excel. So you'll have some problems where they'll just ask you, what is the vertex for this equation? What is the axis of symmetry? And you'll fill those things in. But then you'll have some graphing as well. So I want to show you a problem, what it would look like in Math Excel. So here's one pulled up. So x squared minus 9. All right, so I need to pick the U-shaped parabola. I'm going to put my vertex on there first, is what I would do. When you move this around, notice that change the point in the upper right corner. So that's what I'm watching to make sure I have a correct point. So if it's x squared minus 9, it's going to shift this down 9. So I'm on the point 0, -9. That will be my vertex. And then I need to plot at least one more correct point. So I'm just moving it all around to get another point on the graph. All right, so whether you are plugging in points and making a table like we did in our first problem, or whether you've already caught on to the pattern that I would go over 1, up 1 more point from where I'm at on each side, or I could go over 2, up 4 points from my vertex on each side will work as well. And then I'd save that if I got 2 points and check my answer. Oh, shoot. Let's look at it again. I had the point. I think I have to delete it first, right? Clear it. So I had 0, -9 was correct. And then I did 1, -8. Isn't that what I did last time? Why? Yeah, I moved it down 9. And those would be my x-intercepts at 3. This is right. Click to graph the vertex. Okay, I did. 0, -9 is my vertex. Click the graph to plot a point. 3 zeros on the graph. Your answer. Correct answer. I don't know why it's saying I'm wrong. Because it's the same graph right here. Hopefully you don't have that problem. Let me know if you do. And then you have to type in the vertex. Make sure you do an ordered pair. You put it in parentheses, and so on. All right, we'll move on. So if I look at the next problem, I've got x -2 inside the parentheses. Do you remember which direction that moves it? Right 2. So if I go right 2 from 0, 0, that is my new vertex, 2, 0. All right. Otherwise, if you don't remember which way it's going, you can make a table every single time. I'm not going to make a table every single time because I've done enough problems that I know the transformations and I know the pattern of it. If you have not done enough problems to understand the pattern, then you should be plugging in values for x and double checking. All right, in Math Excel, all you have to do is find the vertex and then find one more point you can plug in. Okay, so then my axis of symmetry, I guess I can put my other points. So here's that same pattern coming from the vertex, over 1, up 1 each side of my vertex, and over 2, up 4 on each side of my vertex. Same shape over and over, unless I have some kind of stretch, compression, or reflection, which I currently do not. Okay. All right, so from here, axis of symmetry is x equals 2. That has now shifted because my x coordinate of my vertex is 2. My domain is still all real numbers. It is always all real numbers. My range, y must be greater than or equal to 0. That's the lowest y value because the minimum is 0. Okay. On number 3, we are going to end up having 2 shifts. All right, I have a +1 inside, that is left 1, and a -1 on the outside, that is down 1. So if I go left 1, down 1, there's my vertex. -1, -1, that's the first thing we'll plot on our graph. All right, from there, it has the same pattern of points if you're understanding, or choose some values of x, plug it in, and test it out. But just like in our last unit, you will graph it on Math Excel, but you will also eventually be tested to graph by hand. So I'm asking you still to try plotting these points. All right, axis symmetry, x equals -1 goes through the x coordinate of your vertex. All real numbers for domain. Range y must be greater than or equal to my lowest y value, which is -1. So that is the minimum value. Okay, so that's translations. That's when we just move things up, down, left, or right. Okay, the next part that we'll talk about will be if there is a number out in front of x squared or out in front of your parentheses. All right, which this one, did yours get changed to a 1/2 for number 2? We're going to change it to a 1/2 because I wanted it to be changed. All right, so just make yours into a 1/2, but we'll look at number 1 first. All right, so I don't have any shift up or down or left or right. So my vertex will start here. Let's take a look at a quick table to see what's truly happening then. So if we use, let's do -2, -1, 0, 1, and 2, things that are close to that vertex, because the further away I go from my vertex, the larger it's going to get, and you probably won't fit it on your graph. All right, so I'm taking -2 and I'm squaring it to get +4, but then I must multiply it by 2. So I get 8. I'm taking -1 and squaring it and I get 1, but then I must multiply it by 2 to get 2. I'm taking 0 and squaring it and multiply it by 2, it's still 0. I'm taking 1, squaring it to get 1, then I multiply it by 2. Taking 2, squaring it to get 4, and then I multiply it by 2. So what happens is every single y value from that original parent graph just got doubled. All right, this is a vertical stretch. In correcting those tests, a lot of errors made in the transformations lesson. All right, so good news is we're still working on it, but bad news, we're still working on it. Okay, so make sure if you're still having trouble with that, you are asking questions on that. All right, so if I'm at -2, it's all the way up at 8. If I'm at -1, it's at 2. And same thing on the other side. All right, so that's been vertically stretched. Normally, my points would have been right here, but they just got doubled, right? Normally, would have been here at 4 and 4, but that distance has now been doubled. It's 8 instead of 4, if that makes sense. All right, make my little U-shaped graph here. And then I can answer my information. My vertex is still 0, 0. I didn't shift anywhere left or right. Axis of symmetry, that line that goes through my vertex would be x equals 0. Domains all real numbers. The range y must be greater than or equal to my lowest value, which is 0. So now if we take a look at number 2, I want you to change that to a 1/2 instead of a 2 so that we can do a vertical compression. Because I didn't have an example of that. But also, not just a vertical compression, we are also moving left 3. So I'll move it left 3, get that starting point, and then we'll look at what that 1/2 in front is going to do to your graph as a vertical compression. So -3, 0. X equals -3. It's always going through the x coordinate of my vertex. I don't even need a graph to look at that. All right, so let's think for a second what 1/2, we've already shifted it left 3. If you just think of 1/2 x squared, you can kind of get where those points will be next. So I'll show you a couple different things you can do. This is typically what I would do. So if I did the same points here, but I plug it into this function, I'm basing it off of my new vertex. All right, I'm just finding, so -2 squared was 4, but I got to multiply it by a 1/2. So that gives me 2. All right, because I just cut it in half of what it normally was. -1 squared is 1, but I got to multiply it by a 1/2. So that gives me a 1/2. 0 stays 0. 1 squared is 1, but I got to multiply it by a 1/2, so I get another 1/2. 2 squared is 4. I cut that in half and I get 2. So when I had a 2, all of the y values were doubled. When I have a 1/2, they were all cut in half. And when I'm talking about the y values, I am talking about from the original parent graph right here. Those y values are changing based on the number that's in front. So I can go ahead and treat these like I'm going left 2 from my vertex and up 2. Oops, I didn't go left 2. Left 2, up 2. Left 1, up half of a box. And then the same exact thing on the other side to match and be symmetric. So it is wider. All right, that would be one way to come up with that. Otherwise, you can choose and plug things into that as a table. But make sure if you're using that one, always use numbers to the left and right of your vertex. So -3 is my vertex, so use -4 is directly left of it. -2, -1. All right, if I go too far away from my vertex and I do something like 2, that point's going to be off of my graph. All right, so if you are choosing to plug points into the original function, make sure you're being smart about what you're plugging in, or it may take you a while to graph. All right, so if I plugged in -4, oops, be -4 plus 3 squared, so I'm squaring -1. Oops, this is supposed to be a half. All right, so -1 squared is 1 times a half is a half. So what I was having you do when we had just this part is taking care of that inside and just filling in these values each time to just a compression or reflection or stretch number in front. Up to you. But we'll still get the same thing. You just go -4, up a half, which is what we already have. Okay, so up to you how you want to do it. I have students that catch on to this, and I have students that have no idea what I'm talking about with that, so I'd say, fine, go back to making tables like you did in Algebra 1. Okay, back to the original. All right, last graph we will take a look at. This one has as many transformations as would be possible, so I guess as hard as it could get. All right, so we have a negative in front. That is a reflection, technically over the x-axis, but we don't have time, or we got time to write it down, but we don't have the space to write it down. The 3 in front is going to be a vertical stretch, but I'll just write stretch for lack of space. Then I have a right 1 and up 4. All right, my vertex then, right 1, up 4. Okay, from here, up to you how you want to decide how to make your next points. You could plug a point. You could choose a value for x that is near the x coordinate of your vertex. So I have 1, you can plug in 0, plug in 2, something like that. I like to treat it as 3x squared and make a table. Because for me, that's something I can do in my head much quicker than up into the original function. And then I'm just treating it, if I do a -2, -1, 0, 1, and 2 kind of thing, that means it's 2 to the left of that vertex. All right, so I'd take -2 and I'd square it and get 4, but then I must multiply it by -3. So that means when I go 2 to the left of my vertex, I have to go down 12, which I believe is all the way down to that bottom. Because I am multiplying those y values by -3. Okay, if I take -1 and square it, I get 1 times the -3 is -3. Technically, you don't even have to plug in the points on the other side. We'll go ahead and go to lunch. Well, I want to say this one thing first. And then because they are just symmetric on each side, so I don't have to plug all those in. And we are back. We'll wrap up this graph. All right, so we gotta fill in our axis of symmetry. So x equals 1, it goes to that x coordinate of the vertex because that's the center of my graph. Domain is all real numbers. Oh, we didn't finish that one, is that what you're saying? And then y, this is the first time we are gonna see a change into less than or equal to because we have a reflection. So this is now the top of our graph. So this is the first time we'll see a maximum value of 4 because that is the highest y value. So we're going to stay 4 or under. And I didn't finish this one, was all real numbers. Range y must be greater than or equal to 0, minimum value of 0. Okay, we've got one more example to take a look at. So you're going to see possibly be given a graph where you have to write the quadratic equation. You might be told that here's the vertex. So my vertex is 2, 4. And then they might give you, here's a point, 6, 0, but they might not even have the graph and say, here's a vertex, here's a point, write the equation. So you'll have a couple different ways you might see that. So we're going to need to put that equation. So if you see it mentioned vertex form, that's the form that we are using today. We'll talk more tomorrow about a different form, and then we'll compare it to vertex form, so we kind of give it a name tomorrow. But if you see that in the directions, just write it in the way that we've seen it written so far. So that general form, right, we'll have x minus h plus k, and then there's a number possibly out here. That's the general form. So my vertex is the whatever number is in for h, and then, or that's my x coordinate, sorry, and k would be the y coordinate of my vertex because that's going to shift it up and down. The h moves it left and right. If it's minus, it'd be positive. If it's plus, it would be negative. So if we know the vertex right now, here's what we can fill in. We don't know if there's a stretch. Well, you might be able to look at it and go, well, there's going to be a reflection. It's flipped over, right? Looks like it's maybe compressed, but the exact amount can be hard to tell from the graph. So we are going to have to calculate that in a moment. But I know I'm shifting this graph right 2, so I need x minus 2. And then I'm shifting this graph up 4, so I need the plus 4 on the outside. Okay, I'll need to calculate what a would be, so I need to use one of the points on my graph. It doesn't really matter what point as long as it lines up nicely, but I wrote that one down first, so I'm going to use this one. So that's my x coordinate and y coordinate, so I'll replace x and y, so I could solve for what a has to be to make this a parabola. So my y coordinate is 0, my x coordinate is 6. Okay, so from here, I'll follow my order of operations. 6 minus 2 is 4. I will need to square the 4, and I get 16. I would not write it like this. This means a times 16. I would always suggest writing it with 16a plus 4, because what I find is students try to add the 16 and the 4 together, and they always get these problems wrong. All right, the a and the 16 are multiplying, so I cannot combine the 4, and you probably would notice if I put it in this form, I must subtract the 4. So now I have negative 4 equals 16a. Divide both sides by 16. So a is a negative 4 over 16, or that's negative 1/4. Math Excel will want you to simplify your fractions. So then my final answer, dy equals negative 1/4 x minus 2 quantity squared plus 4. So hopefully the vertex will be easy to fill in, and then you need to choose a point, or if they give you a point, you plug that in for your x and your y to solve for your a value. All right, that is it for our 4.1 lesson.